All right, so we are going to do an introduction to trigonometric identities. And the first thing that I want to do is just point out what those are. So when we say something's an identity, it means that it's always true. And they're split, and you have this on the first page of the handout, but they're split into some different categories. So the first three are the reciprocal identities. And we've already talked about that. So cosecant x is 1 over sine x. Secant x is 1 over cosine x, and cotangent is 1 over tangent x. And those are called the reciprocal identities because they're inverses. And it's also possible, and it's important to know this just so that you, if you're doing a question, don't get stuck because you don't think you can rearrange these. These are actually able to be rearranged. So it's also true that 1 over cosecant x is sine x if you just flip both sides. And same thing here. So 1 over secant x is cosine x, and 1 over cotan x is tangent x. So you can rearrange these in any way you want, but these are always true, and they're called the reciprocal identities. You have these on the first sheet that I gave you. Then there's two other identities, and there's just the tan x is sine x over cosine x. That is always true. And cotan x is equal to cosine x over sine x. That's true because this is true. It's just the flip, right? And this is true, this tan x equals sine x over cosine x, because if you think about sine x is opposite over hypotenuse, and cosine x is adjacent over hypotenuse. So if I write sine x over cosine x out, I get opposite over hypotenuse divided by adjacent over hypotenuse. And when you're divided by a fraction, you invert and multiply, so you get opposite over hypotenuse multiplied by the inverse of this, which is hypotenuse over adjacent. And what happens is the hypotenuse cancels, and you get opposite over adjacent, and that is tan x. So that's why this is true. This is the proof that tan x is equal to sine x over cosine x. And then this is true just because tan x is 1 over cotan x. So if you flip this over, all right? Then you have three other identities. They're called the Pythagorean identities. All right, and you don't need to know everything about them right now, but you do need to know what they are. So sine squared x plus cosine squared x equals 1. 1 plus cotangent squared x equals cosecant squared x, and 1 plus tangent squared x equals secant squared x. They're called the Pythagorean identities. These are always true. They can be rearranged, so it's possible to write sine squared x equals 1 minus cosine squared x, or cosine squared x equals 1 minus sine squared x. You can rearrange them, and you can rearrange the other ones as well. But where they come from is, you remember your unit circle? We said that sine theta was y and cosine theta was x. Hopefully you remember that. And we said the unit circle formula is this. It's x squared plus y squared equals 1. So if I replace x with cosine theta and y with sine theta, that's where that identity comes from. So there's my identity. So that's the proof of that being true. It's called the Pythagorean identity because it uses the Pythagorean theorem, essentially. All right? X squared plus y squared equals r squared. So you might be wondering, okay, that's great, but what in the world is all this talking about? So here's what trigonometric identities are all about. They're all about proving that something is true, a statement is true. So what we're going to do is we're going to use the identities that are on that first sheet, and there are 8 of them, basically. There's these 3, these 2, and these 3. And we're going to use them to prove that other things are true. Okay, so to prove that they're true, what we're going to do is we're going to start on one side, and we're going to try to make sure that it equals the other. So we're going to start on the left-hand side. You'll see it abbreviated. I always abbreviate it LHS. Or we're going to start on the right-hand side. It doesn't matter which one you start on. But you're going to try to, based on the trig identities that we know are true, and based on mathematical operations like multiplying, dividing, adding and subtracting, factoring, those kind of things, we're going to try to make one side look like the other side. So I'm just going to warn you, there's not a set of steps that you follow when you get the right answer. but there are some hints along the way. So the first thing that you're going to do is you're going to decide where you're going to start. So you're going to pick a side to start on. And the side that you're going to start on, I say, normally is the side that has more stuff. And what I mean by that is if you look at this particular example, this has 2 things in it. This only has 1. So I'm going to start over here. So the way that I write out the proof is I always start by saying what side I'm going to start on. So I'm going to start on the left-hand side. And the left-hand side is equal to, right now, cosine x times tan x. I'm trying to prove that this is equal to sine x. So what I'm going to do is I'm going to go back to my identities. I'm going to look at this one right here. Tan x equals sine x over cosine x. I know that's true. And I'm going to replace it in here. So tan x becomes sine x over cosine x. And then the cosine x's then cancel. So this is just a division. And you're left with sine x. And that's your right-hand side. So we've just shown that the left-hand side that starts out like this is equal to the right-hand side. And then we write down QED. QED is Latin. It's quas est demonstratus, and it means that which was to be demonstrated. So once we've shown that it's true, we can say there, that was what I was trying to demonstrate. So we write down QED. It gives you some math cred, all right? It's kind of like street cred except in the math world. So people think you're cool if you put cred after your proofs. You don't have to. It's just something you should do if you want to be cool. And who doesn't want to be cool? All right, so we're just going to do a couple more examples, and then I'm going to let you try more on your own during class time. But here's another one. Secant x, cotangent x, sine x equals 1. So what I'm going to say to you is this. If you have a bunch of terms on one side and they're all multiplied together, the strategy for proving these is to just make everything into sine and cosines. So I'm going to start, this has 3 terms. This has 1, so I'm going to start on the left-hand side. And I have secant x, cotangent x, and sine x. And I'm going to then write them in terms of cosine x. So secant x is 1 over cosine x. Okay? And I'm just going to try to remove these little bars for a second so you can see what I'm talking about. So I'm just going to take these away. Take these away. So I have secant x is 1 over cosine x. Cotangent x, if you look back at your sheet, is cosine x over sine x. And then I just leave the sine x alone. And then what happens is, and now we'll put the dashes back in, cosine divided out with cosine, sine divides out with sine, and I'm left with 1. And I say there, that's my right-hand side QED. So that's the premise behind trig identities. It's just trying to show that one side is equal to the other using the identities that we know are true. All right, so we'll just do one more example, and then I'll let you do some in class tomorrow. So you just need to sort of have the concept down, all right, as you try them. And of course, it's just trying them. So on Friday when I get back, we'll go over them. And if you have no clue, that's okay. But if you look at this one, I want to prove that cosine x minus sine squared x cosine x equals cosine cubed x. So the first thing that I do, I always start on the side that has more terms. And then what I'm noticing is there's just cosine over here. And here there's sine. So what I'm going to do, there's a cosine x in this term and there's a cosine x in this term. So I'm going to take it out as a common factor. All right? Which means if I remove cosine x here, I have 1 left. And if I remove cosine x from here, I have sine squared x left. So I have 1 minus sine squared x. And if you look back, we had this identity, right? Sine squared x plus cosine squared x is equal to 1. And I told you could rearrange it. So what I'm going to do is I'm going to bring this over to the other side, and I'm going to say cosine squared x is 1 minus sine squared x. So I'm using a Pythagorean identity, and I'm saying, look, 1 minus sine squared x, which is what I have here, is equal to cosine squared x. So I'm going to replace it. And then if I multiply cosine x by cosine squared x, it gives me cosine cubed x. And that's my right-hand side. And then I write QED. Nailed it. So that's how you prove trig identities. The simple ones that you're going to try some, just the front page of the second page. So I think it's questions 2 through 5. They all have mostly just multiplication and then maybe a couple of rearrangements like this. So hopefully that gives you an idea of the concept. It's a very brief introduction. So I understand, you know, if you don't get it right away, that's okay, but I want you just to read the pages, the questions on the page, and try to, based on what I've shown you, do your best to prove that those things are true. All right, have a good time.